Welcome to Geometry Pre-AP. Today we're going to learn about similar right triangles. This is Chapter 9, Section 4. We're going to go backwards a little bit. I did this during this time because we've just spent some time going over Pythagorean theorem, and this does have to do with right triangles. All right, so my nickname for this section is actually called Mama Baby Daddy. I abbreviate that to MBD, and we'll explain why in just a minute. And we're going to learn about what geometric mean is and how to integrate it into geometric situations. That is an Algebra 2 topic that you'll see again then. And also we will learn that if the altitude is drawn to the hypotenuse of a right triangle, then three similar triangles are formed, and those triangles can be used to find side lengths. Now, this is what I just said. I said I got a right triangle. Okay, so here's a right triangle, and I draw an altitude to the hypotenuse, like this. And so when I did it, there's three different triangles formed, and we're going to talk about it. I'm going to remind you always when you come into class, make sure you do the do first when you sit down and know what's going on. All right, so geometric mean. I also titled this Mean Geometry News. Geometric mean of any two numbers, a and b. So a and b are two numbers, and the geometric mean is the value x. And so in Algebra 2, you'll see it done like this. We cross multiply x squared equals a times b, so that x is equal to the square root of ab. And that's how they look at it in Algebra 2. But in geometry, we use it as a proportional setup because it's a proportion, and there's some proportional properties going on here. So let's look at a couple practice problems. So find the geometric mean of 2 and 8. And so here we have our proportion. And remember, if we go backward here, geometric mean was in that spot. So we have x here and here, and our two numbers are 2 and 8. And so this is your proportion. We cross multiply. So x squared equals 16. X is equal to plus or minus 4. And so there we have our correct answer. So then try to do the geometric mean of 4 and 5. Pause the video. All right, when you're done with that one, you should have x is equal to 2 square root of 5, and that's your geometric mean here. All right, this last one, try this last one. See if you can figure it out. Pause the video. Put it back on when you're ready to go. All right, so when you were working this one, okay, your answer for the number should have been 8 over 3. Because it says here, we start off with a little geometric mean proportion. It says one number is 6, the other number we don't know, and that the geometry of two numbers is 4 and 4. And this is what you have to solve. Okay, and when you solve it, you get a fraction 8 over 3. All right, so it says here, theorem 9-3, make sure you highlight that theorem. The altitude to the hypotenuse of a right triangle divides the right triangle into two triangles that are similar to the original triangle and to each other. So if we have triangle ABC, right triangle ABC, and we put that altitude in here, we end up with a bunch of triangles. So put that altitude in here. I put some congruence marks in here just so you could see the marks that we have. And so I take this first figure out here. There's one. Take the green one off. There's another one. And so when I take this one here, I want to realign it. So I'm going to turn it around. And then I'm going to flip it. I think that should do it right there. All right, so now it's lined up with the original triangle. We take this one. Let's flip it also. And let's turn it a little bit. And now that I have it lined up, we can see that the angle marked congruent are all the same. All right angles are all in the same place. And so we know these two, all three of these triangles are similar by angle similarity. And here we've got the baby, the mama, and the daddy. And so let's call it MBD, and mama, baby, daddy. So we have the three triangles that are all, remember that they're all similar, so there are proportions that you can set up for all these. There's a lot of proportions, but there's a couple that if you know the proportion setups, will make these problems very easy to work. I need to be able to take and separate these figures out like this. All right? All right, so corollary 1 to theorem 9-3. Remember, corollary is just something that comes from the fact that we do it. And it says here that the length of the altitude to the hypotenuse, so this piece right here, the length of the altitude to the hypotenuse is the geometric mean. So that piece is the geometric mean of the two lengths of the hypotenuse, this piece and this piece. And so altitude is geometric mean. Altitude is geometric mean of separate parts of hypotenuse, which gets us this formula right here. All right. All right, so you'll need to have this set up memorized. Now, we also know this one as the heartbeat. And it may not be easy to see it this way, but think of it like this. It's like a heartbeat, like you're going in you're reading an EKG, a little blip for your heartbeat. So this is the way they have it called the heartbeat. So if you were actually to look at the triangle drawn like this, right? And so it'd be, and that's the pattern that you follow. So the A, the E, and the B. All right. All right, so let's practice this one for a minute. So here are two practice problems. I will do the first one and you can do the second one. So if we follow the heartbeat, this is the altitude of the hypotenuse. So I got 4 over x equals x over 12. And so then I cross multiply this proportion, I get x squared equals 48. X is equal to 4 square root of 3. All right, so pause the video and do this one. All right, so when you're done with this one, x should equal 3 square root of 5. Okay, if you get that one wrong, make sure you ask how to do that one when you come back to class. All right. So there's another corollary. Corollary 2 to theorem 9-3 says that it has this theorem, so you can highlight this theorem. But if we read a short version of it, the little box here is a shorter version. A leg is the geometric mean of the hypotenuse and the part of hypotenuse adjacent to the leg. So for this one, we call it the boomerang. So if I'm looking at this leg right here, the boomerang means I do A over B over C and then C over B. That's the part of the hypotenuse closest to that leg. Or we can go the other way with the boomerang, which is go to the other leg and it goes that way. And so it looks like the shape of a boomerang. Okay, so we have the leg, which is the geometric mean, it's the same number used twice, and then the whole hypotenuse and the part closest to that leg that you're trying to work with. All right, so here's some practice. I'll do both legs. And so for this first one, remember that start off with a proportion if it helps you. The leg for x is the geometric mean of the whole hypotenuse, which is 20, and the part closest to it, which is 5. The other setup, geometric mean. This is my leg. It goes here and here. The whole hypotenuse, which is 20, and the part closest to it, which goes here. Okay? And so this one we get x squared equals 100. X is equal to 10. All right, here we get y squared equals, let's see here, 300. And so y is equal to 100 times 3, which is 10 square root of 3. All right. Okay, so pause the video and you do the other one. Okay, so for this one, x should be 6 and y should be 6 square root of 3. All right. If you have problems with those, make sure you... Now, remember that we're finding the legs here, so we use that second corollary. When you're finding the hypotenuse on the inside here, when you're using here, that's when you do the first corollary. So make sure you pay attention to which one you're working each time, and make sure you know the formulas. All right, so which method would you apply, and how do you know? And then it says find x. So if I look here, I have the inside altitude, so that means it's going to be the first corollary. Over here, we don't have the inside, that means it's going to be the second corollary. So find the value for each one. And then when you're done, you can check your answer. All right, so know that you're done. These are the two answers you should get. Make sure you have the work that goes along with them. Just having these answers does not give you enough credit. All right, so here's a nice word problem. So pause the video, read through this problem, and then we'll talk about going through it. Okay, so in this problem, you have this robot, and your robot's going to drive from A to C, and it's going to go from A to D, pick up the water bottle, and then you only know the distance of the water bottle from point C, and you know the distance from A to B. So you need to know this value right here, and you don't know that value. All right, maybe this is some sort of little project and you have to figure that value out. So, but we do know that if you have a right angle here and you have a right triangle, that you have altitude to hypotenuse. You have a leg. You don't have the altitude, but you don't need that one. If you needed to find that, you could. you need this piece right here. So we're going to use the second corollary. So the second corollary says that the leg 20 is the geometric mean of the whole hypotenuse, which is x plus 9, and the part closest to the robot that you're trying to find. So then when I cross multiply this, I get x squared plus 9x equals 400. Because it's a quadratic, we want to get it equal to 0. Then we got to factor it. We get x minus 16 and x plus 25 equals 0. Then we make each one equal to 0. So we get x minus 16 equals 0, x plus 25, and so when I do that, I get x is equal to 16, x is equal to negative 25. We can't have a negative 25 distance, so we go with the positive 16 value. So therefore, the answer to this is that the answer would be that the robot has to have 16 inches to travel. And that would be it. So you can have quadratics in the MBD, Mama, Baby, Daddy stuff. Well, in that case here, let's take a look at these. All right. I will work the first one, and you can work the second one. Or actually, I'll work halfway through the first one. So if we look at the first one, because this is on the outside here, that means I'm going to use the second corollary. So I always like to start with my proportion, and my legs go in the same place, and then I have the whole hypotenuse, x plus 18, and the part closest to the 12, which is x. Cross multiply, that's x squared plus 18x equals 144. So that's x squared plus 18x minus 144 equals 0. Okay. So now we have to take this problem and we're going to have to factor it. And so when I factor it, I'm going to get x plus 24 and x minus 6 equals 0. So I get x is equal to negative 24 and x is equal to 6. And I know I can't have a negative distance, so I got to go with x is equal to 6. All right, so you try the next one. See how you do. Pause the video and see what you get. All right, when you're working this one, you should get the answer x is equal to 3. All right. And by the way, it is a quadratic, and you do have to factor it. And that is the end of our lesson.